Hi, I'm Mark Dunning from the Sheffield Bioinformatics Core. In this short video, I'll give an introduction to the R training that we're offering online during this period of lockdown. The R programming language has been around for over 20 years now. It recently celebrated the 20th anniversary of its first official release. It was conceived by two statistics professors called Rob Gentleman and Rossi Harker, as pictured in this New York Times article. And initially they wanted a free alternative to some of the commercial statistics programming languages that were available at the time. So it kind of started in the academic community as being an alternative to other softwares, but it's kind of grown rapidly into a solution that people use for all kinds of different data analytics and visualizations. So here's a case study from Airbnb. In this analysis, they took data regarding where people had booked trips to and from on their website, and they were able to process that network using tools in R, some of which we'll introduce during the course, and they were able to plot it in this nice visualization using a tool called ggplot2. So you don't have to go too far to find other examples of companies you've probably heard of that use R in part of their data analysis, and there's some of them listed here. And you can, if you look at the slides online, you'll be able to follow the links to some of these case studies. One particularly relevant example that I spotted the other day. This was from the BBC News website about confirmed cases of coronavirus, and I'm 99% sure this was generated in ggplot2 from publicly available data. And towards the end of the course, we'll be looking at how we can pull these data into R and start to generate plots like this for ourselves. So the kind of topics that we're going to cover, we're going to look at the R Studio environment, which is the interface that we use to write code in R and manage the files in our project. We'll look at how we can get data into R from a spreadsheet and perform some common spreadsheet manipulations, such as filtering, selecting rows that we're interested in, sorting that data, adding new columns, and doing all kinds of plots from our data. We'll also look at how we can calculate summaries of our data and how we can report our results in a reproducible manner. We'll also look at a couple of examples of joining data from multiple spreadsheets, because quite often in a real analysis we'll have data in multiple tables that we need to join together. So we'll only cover a small set of packages in R. R has many thousands of add-on packages that have been written for doing various specialized analysis tasks. We'll look at this collection of packages that form the tidyverse, which specifically deal with the process of reading data into R, transforming it, so adding new columns, editing existing columns, plotting data using ggplot, and then doing this all in an iterative manner. So you can easily switch between any of these tasks, and how you also communicate the results. Quite a lot of these things you can do in Excel, and people should still use spreadsheets for some activities. So spreadsheets are quite easy to kind of get a eyeball the data and have a quick look at what the data look like, but it's kind of difficult to deal with large amounts of data in Excel and have an analysis that's kind of robust and reproducible. You can inadvertently introduce errors into the data, and it's quite tedious to repeat analysis and process lots of different files, which is something you can quite comfortably do in R. There's a really nice video that I'll put in the description that describes a particularly alarming case of failing to reproduce data from a study. Just in brief, it was a study that was in the New England Journal of Medicine. They claimed to have a gene signature for telling people's prognosis for lung cancer, and the results were not reproducible because they weren't written in R, and there were actually some fairly fundamental flaws in the research that were exposed when these statisticians tried to reproduce the data. We'll be using data from a project called Gapminder, which is a project that collects metrics from different countries over time, such as their life expectancy, population, and income. So you can kind of look for global trends in the way countries are developing. And on the Gapminder website there are some quite nice talks, some quite famous talks on how these data have been used. And it's kind of data that kind of hopefully is understandable to everyone, rather than using a specialised data set where maybe some people in the class won't actually understand the underlying data. So some of the example plots we'll be creating by the end of the course look a bit like this. So we've got different countries and we can plot what their wealth is against their life expectancy and colour in that data according to different factors such as the continent and also the population size. So we can gain insights into our data from a few lines of code, which is almost kind of publication ready. We can look at trends in life expectancy over time and compare between countries and start to gain more insights into the data. So there are some resources available. If you start to use R for yourself, you'll probably run across error messages. During the course we'll explain how some of these errors can be interpreted and tackled, but when it comes to your own data you might need to deal with error messages, and there are various places you can go for help or for inspiration on how to use R. If all else fails, you can always Google a particular error message or a particular thing you want to do in R, and an answer should come up if someone's attempted it before. So, as I said, that's a quick introduction to the R language. The rest of the course will be taught using live coding and kind of demonstration, so there'll be no more slides. But I hope you enjoyed the course and hope it kind of gets you started on using R for your own analysis. And please do get in touch with us at Sheffield Bioinformatics Core if you've enjoyed the course and have any suggestions about how we can improve it. Thank you.